June 2015, question 10a. It says, the diagram below, not drawn to scale, shows a vertical tower, BT, with a flagpole, TP, mounted on it. A point R is on the same horizontal ground as B, such that BR is 60 meters and the angle of elevation of T and P from R are 35 and 42 degrees respectively. I. Label the diagram to show the distance 60 kilometers, the angles 35 and 40 degrees, and any right angle. Alright, first thing, BT is vertical and BR is horizontal, and the angle between vertical and horizontal, this angle here is 90 degrees. That's the first thing. We're told that BR is 60 meters, so this is 60 meters here, and we're told that the angle of elevation of T and P from R are 35 and 40 degrees respectively. So angle of elevation is the angle between the horizontal and the line of sight. This angle here is 35 degrees. It's the angle of elevation of T from R. And this angle here is 40 degrees. Is it 40 or 42? Not 40. It's 42 degrees. So this is 42 degrees. And that represents the bearing of P from R. So I asked us to put in this 4 pieces of information: the right angles, the angles of elevation, and the 60 meter distance. Alright, next we're asked to calculate the length of the flagpole, giving your answer to the nearest meter. So the flagpole is TP, and we're asked to calculate the length of the flagpole. There's only one way we're going to calculate that. We're going to have to calculate the length BP. So we're going to have to first calculate this length BP. I might call it, let's see, Y. And we're going to need to calculate the length BT. I'm going to call that X. And then the height of the flagpole would be the difference between these two heights. Alright, why did we have to go that route? First of all, what we're seeing here is that we have two right angle triangles. Or it would be good if you can see that you have two right angle triangles. There's a larger right angle triangle, and inside of it there's a small right angle triangle. There's also a non-right angle triangle that's at the top here, but we don't have enough information for that, so we can't use it to solve anything. Alright, so we have two right angle triangles, and the tools for solving a right angle triangle are Pythagoras theorem and the trig ratio. So there's no direct path based on the information that we have. There's no direct way of finding the length TP. We have to do an indirect approach. We have to first find the length BP and the length BT, and the difference between the two lengths is TP, which is the height of the flagpole. So using the small right angle triangle, X, where the angle is 35 degrees, X is opposite to the 35 degrees, and the 60 meters is adjacent to the 35 degrees. Now the trig ratio that includes opposite and adjacent is tan. So for I, well, double I actually, I'm going to say tan is equal to opposite over adjacent. Then I'm going to say the tangent of 35 degrees is equal to opposite X over adjacent 60. Then I'm going to say if I have one fraction is equal to one fraction, I'm going to cross multiply. 1 times x is equal to 60 times the tangent of 35 degrees. So x, which is the height of the tower, or whatever it is 60. The tangent of 35, and the answer is 42 meters. So BT is 42 meters. Let us determine BP, which is y. BP is is one side of the large right angle triangle, where the angle is 42 degrees. So y would be opposite to the 42 degrees, and BR is adjacent, and the ratio that includes opposite and adjacent is tangent. So the tangent of 42 degrees is opposite y over adjacent. If I have one fraction is equal to one fraction, to get rid of the fractions, I could cross multiply. So 1 times y is equal to 60 times the tangent of 42 degrees. So y is equal to, this is 60 tan 42 degrees. Alright, and y is equal to 54 meters. Now, therefore, TP, which is the height of the flagpole, would be equal to 54 meters minus 42 meters, which is equal to 12 meters. So the height of the flagpole, TP, is 12 meters. Alright, and that brings us to the end of this section of the question.